Hello, 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 everybody. Root Beer here, hoping you're doing well and hoping that you're eager to continue on with question number 8 on the 2010 MNC paper. All right. A line with slope 1 meets the parabola y equals x squared at A and B. If the length of segment AB is 3, what is the equation of that line? All right, well, let's draw ourselves a bit of a picture. We know the parabola, and we could definitely draw better axes than that. Yeah, close enough. And we'll just redraw our x-axis so it meets the parabola rather than try and redraw the parabola. All right, and then we have a slope of 1, so it goes up and to the right, and we hit at 2 different points, A and B. Okay, now we know it's y equals x squared, and we know it's y equals mx plus b. I'm not going to call it b, however. I'm going to say we know we have a slope of 1. Okay, because what I'm going to do is I'm going to say something like A have coordinates A and A squared. It's on the parabola, so that's got to be true. And B, we're going to reserve the little b for the x coordinate of B. Now, since the slope is 1, and we have 2 points on the line, we can say b squared minus a squared is b minus a. But hey, that's difference of squares. So that tells me b plus a is 1, or a plus b, depending on how you want to write it. Okay, so that's nifty. A plus b is 1. What else did they tell us? Well, they told me the length of the segment. So 3 is AB. Now, how do we figure out the distance here? Well, we either know the distance formula, which many people do, or we can do a simple sort of right angle triangle here. What's this height? This is b squared minus a squared, difference in the heights. And this distance here is b minus a. Okay? So where slope of 1 gives us a rise over run sort of argument, if I view this as a right angled triangle, Pythagoras tells me another thing. And this is the common distance formula, the difference in the x-coordinates squared plus the difference in the y-coordinates squared. Okay? And so that's 3. I'm going to square both sides and say 9 is b minus a squared plus, and I'm also going to factor this. I don't know whether or not this is going to help. Oh, it does. It's going to factor as b minus a squared, and then this becomes b minus a squared, b plus a squared, because we'll slow it down for a moment. We still have the whole thing squared, but b squared minus a squared is b minus a, b plus a. And now the squared gets applied to both of them. But this is just 1. So this is 2b minus a all squared. Well, great. Now I can solve for b minus a. And since I know b plus a, I can solve for b and a. So 9 over 2 is b minus a squared. Square root both sides. 3 over root 2 is b minus a. One of them's positive. I mean, you can get the negative one, but that just interchanges b and a, so don't worry about that. And we also know 1 is b plus a. So if we add them both up, we get 2b. I'm going to rationalize the denominator really quickly. Just multiply top and bottom by root 2. And I'm going to change this to a 2 over 2. So 2b is 3 root 2 plus 2 over 2. b is going to be 3 root 2 plus 2 over 4. And plugging that back in, we could get a, or we could say, 3 root 2 over 2 is b minus a. And then subtract off 1, which is b plus a. And we'll get negative 2a on one side, and 3 root 2 minus 2 over 2 on the other side. So a is going to be 2 minus 3 root 2 all over 4. So not particularly nice numbers, but then again, not horrible numbers either. And actually, the way this looks makes me think that we could have set up a quadratic. Right? Because a and b are both roots of 2 plus or minus. They look like this. Okay? So we absolutely, I think, could have said a and b are the solution of some quadratic. I didn't have a quadratic. But I guess if we took this one here and rearranged and wrote a is 1 minus b and plugged it back in, we would have gotten a big old quadratic for b. And that would have been fine. Now, they didn't just ask me for the x-coordinates. They asked me for the actual coordinates. Oh, no, they asked me for what is the equation of that line. Okay. So we could do y equals mx plus b, although I'm loath to say that. I'm going to use point-slope form. Say it's y minus a specific y value, so a squared, is equal to mx minus a. So that'll be y minus a squared is equal to x minus a. I do need to square this a here. So we could say it's y minus 2 minus 3 root 2 all over 4 squared equals x minus 2 minus 3 root 2. All over 4. I probably actually should have used the b values, but it doesn't really matter. X or y minus 4 minus 3 times 2 times another 2 is 12, so minus 12 root 2 plus 3 root 2, so that's 18 all over 16 equal to x minus 8 minus 12 root 2 all over 16. Bring this over to the other side and get it in y equals mx plus b form. Y equals x minus 8 minus 12 root 2 all over 16 plus 22 minus 12 root 2 all over 16. Change this to a plus, put the minus signs up there. These cancel out, and it's 22 minus 8 over 16. So y equals x, 22 minus 8 is 14, x plus 14 over 16. So that's a little strange. I guess we could simplify that. So y equals x plus 7 over 8. So in theory that should work. I'm going to double check that my b and b squared work here as well. So this is just me double checking. B squared equals b plus 7 over 8. So that would be 2 plus 3 root 2 all over 4 squared plus 2 plus 3 root 2 all over 4 plus 7 over 8. So that's 4 plus 12 root 2 plus 18 all over 16 is equal to 8 plus 12 root 2 all over 16 plus 14 over 16. 8 becomes a 10. 4 and 10 is 14. And the 12 root 2's, yep, so it works out. Okay. That's just weird. I don't know why it'd be 7 over 8. But I'm sure I could figure out why it's 7 over 8 if I changed the length of segment AB from 3 to something like K and get a formula in terms of K. But really, that doesn't matter right now. We got 2 more questions to go on this contest. Question number 9 and then finally question number 10. So I will see you guys in the next video for question number 9. Feel free to give it a try before watching the video. And I'll see you there.